Alright, in this video we're going to be solving for Thevenin voltage. So if you recall, Thevenin voltage can be found. So I'll redraw the circuit over here. So we have this circuit, which is basically a black box. And then we're going to apply some load resistance to it. Now, Thevenin states that this black box, if I wanted to, I could replace all of these resistors and independent sources, or dependent sources. I could replace them with a single voltage source in a single resistor series. From the point of view of the resistor I hook up here, this circuit and this circuit do the exact same thing. So if I want to find out what V Thevenin is, then I go find out what V open circuit is. So I remove the resistor over here and I go look for V open circuit. So that's what we'll do here. So let me fill in the numbers real quick. So we have 6 ohms, 3 ohms, 2 ohms, and 12 ohms. So I'm going to write an equation in terms of V open circuit. I'm going to do a KVL. And I'm going to go ahead and just label some mesh currents. So I1, I2, I3, you can label them in whatever direction you want. So I'm going to go around the outside of this thing. So I'm going to have I1, I2, and I3. I'm just going to go around the outside. This is sum of voltage equals 0. So I will start at the 12. So minus 12 plus 6 I1 plus 3 I2 plus 2 I3 plus V open circuit. So the point of this equation is to get V open circuit. So I want to solve for this. So that means I need to find I1, I2, and I3. Well, if you look at this, you can see that I have an open circuit here, which means there is no current. This happens to be I3. So I3 will go away. It'll be 0. And if this goes away, that means that this current I2 is equal to negative 2 amps. It's negative because the arrows don't match. So as I2 goes around, so it'll be going down, and the arrow for the 2 amps points up. So they're in opposite directions, so I need a negative sign to flip one. So then I can rewrite this equation. And so now I have two variables. I have I1 and V open circuit. So I just need one more equation to solve this. That equation will come by doing a KVL around I1. So if you remember from mesh current analysis, don't do a KVL on I2 because I don't know the voltage for this 2 amp source. So we'll do a KVL around I1. So voltage equals 0. So again, minus 12 plus 6 I1. And then I'm going to come down through this 12 ohm. And that will be I1 minus I2. And that'll all be equal to 0 when I get back around. I can sub in for the I2 in a second. So negative 12 plus 6 I1 plus 12 I1 minus 12 times I2. And we know that I2 is negative 2, so I'm going to put that in. So this negative goes here, and then the I2 goes there. So this only has I1 in it. I can solve for I1. I1 will be negative 12 over 18. We'll be what we get for that. And then we just plug it back in up here. So this is just algebra at this point. And find that V open circuit is 22, which is also V Thevenin. Because remember, V open circuit is V Thevenin. Alright, so it's kind of recapping. We have a black box with a resistor we're going to plug into it. It doesn't matter what's inside that black box as long as they act the same. So I can either have this circuit or this circuit. From the point of view of the resistor I will plug in between B, these do the same exact thing. If I go find V open circuit, I can figure out what this Thevenin voltage has to be. And in this case, it is 22.